Hello, today we are going to see the use of resource allocation graph in a multiprocessing operating system to detect a deadlock. First of all, let us see what is resource allocation graph. A resource allocation graph will contain a following number of nodes, a total number of shared resources which are connected with a system, and total number of processes which are executing simultaneously by the system. And these are the number of edges which shows a allocation of resources to the process as well as a processes which are requesting for more number of resources for the execution. Now we are going to see why it is required. Through resource allocation graph, it is possible to check the status of the processes which are there in a part of deadlock. This is the example of resource allocation graph, how it looks like. You can see in this resource allocation graph, there are three processes, process P1, process P2 and process P3. As well as four resources are there, shared resources among these three processes, resource R1, resource R2, resource R3 and resource R4. Now in this graph, resource R1 and resource R3, these are the two single instance resources. It means these particular resources can be allocated to only one process at a time. Resource R2 and resource R4 are the multi-instance resources. It means resource R2 can be allocated to two processes at a time, as well as resource R4, it can be allocated to three processes at a time. Now let us check the notations first of all. The circle which represent a node in a resource allocation graph for the processes. A square that will be used for resource, and inside the square you can see this dot which represent a total number of instances in a particular resource. Now this is a single instant resource and this one is a multi-instant resource. That means this resource will be allocated to three processes simultaneously and remaining two, and most critically notations in a resource allocation graph, that is a direction of arrows. In this notation you can see the direction of arrow is there from resource to process. It means a resource R has been assigned to process P. It means process P is right now accessing this resource R. And second one is a totally reverse direction. An arrow is there from process to resource. It means a process P is now requesting to access resource R, but still the resource R has not been allocated to process P. It is just requesting. It may be possible that this resource R will be used by another process. That's why it will not be granted to this particular process. So these are the two critical notations and through which we should have to identify the deadlock. Now let us see an example of resource allocation graph. Here is the small demonstration of resource allocation graph. Right now the status is resource R2 is being used by process P1. That means R2 has been assigned to process P1. Next, resource R1 has been assigned to process P2. Resource R3 has been assigned to process P3. Now R2 is a multi-instant. two instances are there for resource R2. That's why it can be assigned to two processes. First of all, it has been assigned to process P1 and now it has been assigned to process P2. Now look at that. Process P1 is requesting to access resource R1. R1 is a single instance resource and it is already been accessed by P2. That's why the request of process P1 will not be granted. Process P1 has to wait for resource R1 until and unless it has been completed the task by process P2. Same situation for process P2. Now it is requesting to access resource R3. Again it is a single instance resource and this resource has been assigned to process P3. That's why the request of process P2 will not be granted. Process P2 has to wait for resource R3. Now, this is what about the current status of resource allocation graph. Process P1 and process P2 are waiting for resource R1 and R3, whereas resource R1 and R3 has been accessed by process P2 and P3 respectively. And resource R2, which is a multi-instance resource that has been accessed by process P1 and P2. So right now process P1 and P2 are in a waiting state and they are waiting for resource R1 and R3 respectively. Now let us check the further status. After completing a process P3, now process P3 has completed his task, resource R3 has been released by process P3. Now that resource has been granted to process P2. That means the request of process P2 is now accepted, but after completing a task of process P3. But if process P3 is not completed and then suppose P3 is also required the use of resource R2 before completion, so it will send a request to resource R2. Now all the instances of resource R2 are occupied by process P1 and P2. That means process P3 has to wait until and unless resource R2 will be released by process P1 or process P2. But now you can see process P1 and P2 are already in a waiting state. So there is no possibility of releasing a resource R2 by P1 or P2. That means it cannot be allocated to process P3, and that's why process P3 will not be completed. And until and unless process P3 will not be completed, resource R3 will not be released. And until and unless resource R3 is not been released, it cannot be occupied to process P2. And process P2 cannot release the resource R1. And until and unless resource R1 will not be released, it cannot be occupied to process P1. So in this case, all three processes P1, P2 and P3 are in a waiting state. Process P1 is waiting for resource R1, process P2 is waiting for resource R3, and process P3 is waiting for resource R2. So this is a cycle. This is a cycle, and this cycle shows that process P1, process P2 and process P3 are there in a waiting state, and it is an infinite waiting time. No one will be released, so it is a situation of deadlock. So in that way, using resource allocation graph, we can detect a deadlock, that which processes are a part of this particular deadlock situation. In this case, a cycle is created by all the three processes. That's why process P1, P2 and P3, all three processes are a part of deadlock. Thank you.